There are two types of memory, random access memory and read-only memory. The first type of memory is random access memory, or RAM for short. There are two types of RAM, and they are static RAM and dynamic RAM. Static RAM is faster than dynamic RAM. However, static RAM also costs more to manufacture. The second type of memory is read-only memory, or ROM for short. There are multiple types of ROM, and they are programmable read-only memory, or PROM, erasable PROM, or EEPROM, electrically erasable PROM, or EEPROM, or flash PROM. Static RAM means that the data can be stored as long as there is power being supplied to it. RAM means that the data can be retrieved from any location, unlike conventional storage where the data needs to be retrieved sequentially. Static RAM can be manufactured using two designs. It is either a D-type latch or a 6-cell transistor. D-type latches are used for functions like computer registers. A D-type latch is derived from the inverted RS flip-flop. A D-type latch has two inputs and two outputs. The two inputs are an enable port and a data port. The two outputs are Q and Q naught. When the enable line is 0, the RS flip-flop holds the previous value. When the enable line is 1, the data input will be latched into the RS flip-flop. Edge-triggered D-type registers are mostly used in combinational circuits where it is more important to have them respond to clock pulses. When the clock is 0, the first D-type latch is on, and the data is latched into the first flip-flop. When the clock is 1, the first D-type latch is turned off, the second D-type latch is enabled, and the data is transferred from the first to second latch. Transistor cell RAM is not very efficient because the transistor count per bit is too high. To read the data stored, the bit lines are charged high, the WL line is turned high and will turn the M5 and M6 transistors on. If Q naught is 0, then the value is retrieved from the M5 transistor on the BL line. If the value of Q is 1, then the value is read from BL. To write, send the value that needs to be stored to the BL and BL naught lines. The WL line is triggered and the value is latched into the storage cell. However, the bit line drivers must be stronger than the transistor for the value to be stored. Single SRAM bit cannot be written to when A is equal to 0, and D out will also equal 0 at this time. When A is equal to 1, the latch is enabled. If W is equal to 1, data can be written to it and the output gate is enabled. If W is equal to 0, the new value for D in is not stored, however, the output gate is enabled. Since static RAM requires multiple transistors per bit, it becomes difficult to make it cost-effective. However, dynamic RAM can be done with just one transistor, therefore making it cheaper to manufacture. In dynamic RAM, silicon dioxide will insulate the gate and substrate. The data is stored with the capacitance that is charged. The charge will slowly weaken over time, so it has to be recharged in order to prevent data loss. When dynamic RAM is refreshed, it needs to read the data bit and rewrite it back to the same cell. JEDEC standardized that it must refresh every 64 milliseconds. Due to this constant refreshing, there is dedicated hardware to refreshing the RAM, so the refresh doesn't affect the performance. This 8x8 array makes up a 64x1 dynamic RAM storage. Each row and column are made of address decoders. The 8 rows and 8 columns each need 3 address bits. RAM is used in a computer to store data that does not need to be stored in long-term use and needs to be written and read very quickly. RAM can be used in computers, planes, cars, and medical products.